Good morning, student. Today we are taking some numerical based on the electric field and electric dipole moment. So, first here two numericals are. We are solving each of them one by one, and then we go for the other numericals. Okay. Solution. Now first we taking this problem, which is second problem, that is an electron is separated from a proton by a distance of 0.54 angstrom. Calculate the electric field at location of the electron. So student, here we have charge on electron, that is minus 1.6 into 10 to the power minus 19 coulomb, and charge on proton, that is 1.6 into 10 to the power minus 19 coulomb, and they are separated by a distance r 0.54 angstrom. We can resolve this value, that is r is equal to 0.54 into 10 to the power minus 10 meter, and the distance between electron and proton is this. So we have electric field due to a point charge, because we need to calculate here electric field due to electron, okay, on proton at this distance. So we have the formula electric field due to a point charge, that is E is equal to 1 upon 4 pi epsilon naught Q upon R square. Okay student, now we are resolving this value by putting the values in the formula. This value initially I am giving you, that is 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9. So we are using this value here, that is 9 into 10 to the power 9 into charge on electron, we are using QE, that is minus 1.6 into 10 to the power minus 19 upon the distance between at the point where we need to calculate the electric field, that is 1.4 into 10 to the power minus 10 square. So now we are solving this value, that is 9 into 10 to the power, we are using here student okay, 10 to the power 9, 9 is solved by minus 10, we using this here student. When we are adding plus 9 minus 19, we get the result is minus 10. So we are using here the same value, and into 1.6 upon, we are using 54 or same value, that is 0.54 into 0.54 into 10 to the power 2 into 10, that is 10 to the power minus 20. Okay, now by cancel this 9 by this 54, we are getting 0.6, and when we multiplying this 5 into this 3, we are using here this as 50 approximate value, and this multiply 6, so 5 into 6 become 30, so this value become 1.6 into 10 to the power minus 10 plus 20 upon, by using this, okay, we are multiplying thoroughly, 6 into 4 24, 4, 6 into 5 30, and 2 32, and we are putting here 1 0 and point, because here after decimal there is 4 points, 1 2 3 4, so we are using this. Now 3 5 ja 15, and this 24 multiply to become this, or we are getting this value is equal to, first we solve this value, then we resolving it. Okay, this point shifted here, and then 16, okay, 1.16 0 into 10 to the power 10 upon 3.24. Okay, we are using here 1600 कर लेते हैं स्टूडेंट, and here we are using 2.4 32.4, so this 0.4 we are using as 0, and this 32 cancel this by 20 time, by 5 time, and here we are using this 0, so we are getting this value is 50 into 10 to the power 10, or we are using 5 into 10 to the power 11 Newton Coulomb. Okay student, so copy this answer. Okay student, let me correct the power 10. Okay, this is final answer, 5 into 10 to the power 11 Newton per Coulomb. Now we are going for solving the next problem. That is problem number 5. In this problem, we have to find electric field due to a charge at a point 50 centimeter from it in air if charge q is equal to this. Okay, so we have the same formula. Given is q is equal to 5 into 10 to the power minus 8 coulomb, and distance at where we need to calculate electric field is 50 centimeter. We are using this 0.5 meter only. So by using the formula for the point charge electric field, we have 1.49 1 upon 4 pi epsilon naught q upon r square. By putting these value in this, we have 9 into 10 to the power 9 in place of 1 upon 4 pi epsilon naught, and this is 5 into 10 to the power minus 8, and this value is 0.5 square. So student, when we are solving this value, we are getting 9 into 10 to the power minus 9 into 5 into 10 to the power minus 8 upon 0.5 into 0.5. Okay, now this 0.5 cancel by this 10 time, and this 0.5 cancel this 9, time. Okay, now this 9 into 9 ठीक है. Now we are solving this 18 into 10 to the power 10 minus 8, or 18 into 100. So we have the result for this electric field is 1800 Newton Coulomb. Okay, Newton per Coulomb. So copy this solution. Okay student, we have the another problem, that is 2-point charge, each of 3 into 10 to the power minus 6, one is positive charge and one is negative charge, are located at 20 centimeter apart in air. We have to calculate here first electric field at midpoint, and second we need to calculate if a positive charge of 1.5 into 10 to the power minus 9 coulomb is placed at the center, then we need to calculate the force experienced by it. So first we are making this problem to solve easy of this conceptual problem. These are the two charge, one is at point A, one is at point B. So this one we take as plus q charge, that is 3 into 10 to the power minus 6 coulomb, and this is minus q charge, that is minus 3 into 10 to the power minus 6 coulomb, and the distance of separation is 20 centimeter. Okay student, now we taking this given charge plus minus 3 into 10 to the power minus 6 coulomb, distance of separation is 20 centimeter, we are using 0.2 meter, and we need to calculate electric field due to these two charges at the center. So suppose we have a text charge here at point O, we are using this charge as Q, and because it is at the center, so distance between this A to O is 0.1 meter, and from point this to this is also 0.1 meter. Okay student, now we are going to calculate the value of electric field due to the charges at this point O. Okay, therefore we have the formula of electric field, that is 1 upon 4 pi epsilon naught Q upon R square. Here student, the value of this Q is, we are using this is Q1 and this is Q2 or other things, that is the total charge due to which this is experience a force at point O, that is Q1 plus Q2. Okay, so we have the value, charges are the positive or negative, but when we solve these, so remember the charge is scalar quantity and it is only added for this kind of problem, because the positive charge applied here and negative charge applied here and the charges are negative, so opposite direction की वजह से क्या हो जाएगा, वो दोनों ही charges, when we resolve this problem, electric field at A, electric field at B, so A plus B, and we have the value of electric field B is in negative form, so it will be added, that is 3 plus 3, and microcoulomb we are using, so this will become 6 microcoulomb. So we are using here the same way, 1 upon this value we are using directly 9 into 10 to the power 9, and here this is Q1 plus Q2 upon this 0.1 square, so we have 9 into 10 to the power 9 into 6 into 10 to the power minus 6 coulomb upon 0.1, 0.01 we are using, the square of 0.1 is 0.1, so this will become electric field at the point is 9 into 6 is 54, this will minus 3 into 10 to the power 3, and from denominator we have 10 to the power 2. So the field is 554 into 10 to the power 5 Newton per Coulomb. And we need to calculate, second problem is, if at O Q is equal to 1.5 into 10 to the power minus 9 Coulomb is placed, therefore force experienced by it, we have the value of force is Q into E. Here E is calculated and we have the value Q because it is a positive charge. So 1.5 into 10 to the power minus 9, and this value is 54 into 10 to the power 6. So student, we calculating this, 15 into 10 to the power 8 into 10 to the power 5 into 54. So we have a student, by multiplying 15 4 ja 60, carry 6, 15 5 ja 75 and 6 is 81 into 10 to the power 1 minute, this value is minus, so this will become minus 10. On solving this become minus 5, and the final result is 8.1 into 10 to the power minus 3 Newton. This is the result. Calculate, copy this. And because this is positive charge and this is also positive charge, so the electric field in the direction of AO okay, along OA. Okay. Okay student, now we are going to take another problem. Okay student, we have the another problem, that is 2 point charges plus q and minus 2q are placed at the vertices B and C of an equilateral triangle of side A. find the expression for the magnitude and the direction of electric field at point A due to the two charges. So first we are drawing the problem as in question. This is point B, this is point C. Here a charge of plus Q and here a charge of minus 2Q is placed, due to which we need to calculate electric field at the vertex A. Okay, student? Because it is an equilateral triangle, so all sides are equal. Now, electric field due to plus Q charge at point B, because we using at point A here is a test charge, and we all know the test charge is always taken as positive. So electric field due to point B at A is electric field on point A due to B. And student, electric field due to point C at A is electric field at point A due to point C. So first we calculate the value of electric field or due to the charge at point B and charge at point C. Therefore, from figure we have electric field at point A, electric field at A due to plus Q charge is EA is equal to 1 upon 4 pi epsilon naught Q upon A square. This is equation first. Second, and electric field at A due to minus 2Q charge is electric field due to point B is equal to 1 upon 4 pi epsilon naught 2Q upon A square. Okay, student. Therefore, we are able to calculating this electric field E B is equal to 2 into electric field at EA, as you find by these two relations. Okay, student. Now we are using here parallelogram law for adding these two fields by completing rectangle This is the resultant electric field at point A along the direction of BC. So we are using resultant electric field is given by EA square plus EB square plus 2EA EB cos theta. Okay, now we are using here the value from this relation. We are getting EA square plus 4EA square plus 2 into 2EA square cos theta, because we have EB is equal to 2EA. Okay, student? Now this EA square is common as EA, and we have in the square root 1 plus 4 plus 4 cos theta. Okay, student? Now we are finding the value of angle theta, this from the figure. We all know, student, every angle of equilateral triangle is 60 degree. Therefore, by external angle of triangle we are using to calculate this angle as 120 degree. So we are using in place of theta 120 degree. By putting this value here, EA is equal to 5 plus 4 cos 120 degree, and by 1 minute, EA is equal to 5 plus 4 cos 120 degree. Student, we can solve this value as EA under root 5 plus 4 cos 90 plus 30, and cos 90 plus 30 in the second quadrant, and in the second quadrant the value of sine and cosec is positive and rest values are negative. So this value becomes 5 minus 4 sine 30, and student, we know the value of sine 30 is EA is equal to EA in the square root 5 minus 4 into 1 by 2. This 1 by 2 cancel 4 by 2 time. So we are getting the result EA is equal to EA under root 3. Now we are placing the value EA in resultant electric field, that is E resultant at point A. Oh, 1 minute. this is C, this is B, CB, we are using B, we are using B, we are here also using B, because this is due to B and this is due to C. So we are using here B and here C. So resultant electric field at EA, ये कहेंगे हम इसको EA. So this will become B, this will also become B, this is become B, this is also B, this is B and this is B. Okay, the value of electric field B is 1 upon 4 pi epsilon naught Q upon A square, and we have this value root 3. This is the required relation for the expression at point A due to the two charges, and the direction we need to calculate. So we are using the formula direction of EA is, we are using these are the theta. So we are using here suppose this will make an angle this is the angle alpha. So we need to calculate this alpha along AEB. So tan alpha is equal to this is alpha 90. Okay, EB sine 120 degree upon EB plus EC cos 120 degree. So student, when we solve this, we get EB into root 3 by 2, and here EB plus 2 EB and minus 1 by 2. So we have this result 2 EB. EC and this is EB. So this will become 2EB and this is this. Okay. So this will become root 3 by 2 EB root 3 by 2 upon EB 4 minus 1 by 2. This EB cancel. These two cancel by this. So we are having the value root 3 by 3 become 1 by 3, 1 by root 3, and this is tan 30 degree. Therefore, the direction of the electric field is at 30 degree from the projection. So calculate, student, copy this all notes. In the next topic, we are discussing about the electric flux and the Gauss's theorem, and then after we are going to take some application from Gauss's theorem. Okay, student, thank you.